First of all, don't think this is a larger video. You have to watch until the end. Then only you will understand this entire concept. So let's get into our video. Hello friends, my name is Rakesh. Welcome to my channel Rakesh version. So in this video, we are learning about dynamic analysis of slider crank mechanism. So in this we need to find first velocity and acceleration of the piston, and then afterwards next topic is our angular velocity and angular acceleration of connecting rod. So first in this we are finding the piston velocity and acceleration. So first we need to find out velocity, we need to find first displacement. So first we need to set up this, first we need to draw this diagram. So this is the cylinder and inside there is a piston, and also this is the L is nothing but this connecting rod, and this is the crank, and we need to locate the points. So this is the top dead center and this is the bottom dead center of the piston. So here TDC and BDC. So we need to calculate the piston movement and piston stroke, that means TDC to BDC length, how much it is moving. So first we need to locate B and B1, and again this is the angle beta, and this is the length of the connecting rod L, and this is the length of the crank R. So this is the perpendicular distance Y, and this all those points we have to locate A, O. This is the inner dead center. So this is the out dead center. This is the crank. So in this first we need to find displacement. So in displacement of the piston, so from here to here. So first x equal to, we need to find this distance. So B1 distance we have to find out, B1 B. So for that we have to subtract BO minus B1 A. So in this total length from B to O we have to subtract B1 A1. So this is the length we have to subtract, then we get B1 distance. So this is how we are getting the displacement. So then we have to simplify this length. So BO minus B1O. So in this B1O we can replace B1O, we can replace as B1A1 plus A1O. So like that we can write. So you need to follow me, so then only you will understand. So B1O, here first step is completed with replacing of B1O. So second step we are replacing BO. So BO, so when the piston moves from this bottom dead center to top dead center, then the crank and connecting rod gets straight. So the length from B to O becomes the L plus R. So this is the L plus R distance. So BO we can write as L plus R, and this is the step. Here B1 A1 plus A1O, and also we can write as we have to simplify. Our main aim is to get simplified. So B1 A1, so we are writing here L cos beta. So how we are writing this one? Cos beta we have to take. Here B1 A1 length. So you understand that how you can write. So B1 A1, here this is the distance. So if we take cos beta here, so adjacent by hypotenuse, B1 A1 by L. That means cos beta here, if we take cos beta here, B1 A1 by L. This is adjacent, this is the opposite side. So L. So here B1 A1 equal to L into cos beta. So this is how we are writing B1 A1 equal to L cos beta plus A1O. A1O again we can write as R into cos theta. So if we write here cos theta, that means cos theta equal to adjacent by hypotenuse. So here adjacent by hypotenuse, that means A1O by R. So A1O by R. So this is the distance. So if now A1O equal to R into cos theta. I think you understand this one. So this is the a1o distance. So to find out a1o distance, we are taking here cos theta. So cos theta equal to adjacent by hypotenuse. So a1o by r we took here, a1o by r. So here we need to get a1o. So a1o equal to r into cos theta. This r changes into divide, changes into multiplication, r into cos theta. So this is how we simplify this lengths. So next thing, here we wrote, instead of L we wrote here NR. That so angle of obliquity equal to N equal to L by R, L by Rn. This is the thing, angle of obliquity N equal to L by R we need to take. So in this we are writing L equal to R into N. That's it. R becomes multiplication to N. So N into R plus R minus, wherever L is there we have to replace with NR, N into R cos beta plus R into cos theta. So this is the same thing we have to write here. Next step, and the next step is we have to take the R as common. So then we are writing as N plus 1 minus N into cos beta plus cos theta. So we are removing the R, and that is the thing we wrote here. So in this we don't know the cos beta. Our main aim is to get displacement, so we have to reduce all the values up to that. We cannot remove the up to, we cannot simplify the values. So that here we know cos beta here. So in this diagram we are knowing the cos beta, so that we have to replace cos beta by this diagram. So when we take cos beta, and that means cos square beta minus sin square beta equal to 1. So this is the mathematical formula. So in this cos square beta plus sin square beta equal to 1. So cos beta equal to 1 minus sin square beta. So we are finding the cos beta. So that's what we are taking all the values as another side. So in this sin square beta, so sin square beta, if we take this one sin beta, that means opposite by this hypotenuse L by y by L. That's it. Wherever we are seeing the sin theta or cos theta, just we have to go to the diagram and we have to check there. So we know now sin beta equal to y by L. So here square is, so here we are finding square. So that's what we are writing, y square by L square, 1 minus y square by L square. Then we get 1 minus r sin theta by L square. So then you are getting another doubt, why we are writing y instead of r sin theta. So again we have to go to here. So sin theta equal to opposite by hypotenuse y by r. So you have to initially write all those things, whatever the angles are there. Sin theta equal to what is the opposite by hypotenuse. So now we want y value, so r comes to here. So r sin theta, that's it. So r sin theta, here square is there, no? So that's what we are writing, square, r square by L square. Again I told that wherever L is there you have to write Rn. That means we are writing instead of L Rn here. So Rn also it becomes r square and n square, because here L is square in this square, L is in this form of square. So 1 minus r square sin square theta by r square n square. So we are removing r, so it is cancelling. So then now we get 1 by n into under root n square minus sin square theta. This is the cos beta formula. We got cos beta formula. This we have to substitute in this equation. What we got the final equation from the last one. So this is our equation. So we are replacing cos beta as 1 by n into under root n square minus sin square theta. So x into, then we have to simplify, that's it. We are replacing this cos beta in this equation, and we have to simplify. X equal to r into n plus 1, this one we are writing just simplification, that's it. Under root n square minus sin square theta plus cos theta. And then finally we have to reduce the whatever the terms in the equation, we have to reduce them and we have to eliminate maximum. Our aim is to eliminate the things, eliminate the values. So finally here we got x equal to r into 1 minus cos theta plus n minus under root n square minus sin square theta. So here compared to sin square theta, n square is the larger one, so we are eliminating these values. So now we got the connecting rod, and connecting rod is large. So because of the connecting rod is large, n value is so much big, so that's what we are eliminating these values and we are getting x equal to r into 1 minus cos theta. So this is the equation of the simple harmonic. What we got the final equation, the displacement, that is the equation of the simple harmonic motion. So that's what we are writing this equation as simple harmonic motion. That's it. So we know that. Now we got a displacement. Then afterwards, this velocity is nothing but the displacement by time. So now we know the displacement. So and we have to differentiate with the time, dx by dt. So we are multiplying d theta. That means we are multiplying and dividing. If we cancel, there is no that means there is no problem to write and division and multiplication. So this is the thing we have to do first initially, dx by dt, and we are here adding d theta into d. Here we are d theta is a multiplication and dividing we are doing. So I think you understand this one. If we eliminate, there is no problem. D by d theta, instead of x is the displacement. What we find this back, x equal to r into 1 minus cos theta. So this we have to substitute instead of x here. So d by d theta, instead of x we are writing the displacement value, displacement equation, whatever we got. So r into 1 minus cos theta. And now we are writing the final equation, not the when the connecting rod is large we eliminate some values, no. So that is the thing you should not write in that. The final equation, 1 minus cos theta plus n minus under root n square minus r sin square theta. This is the equation you have to substitute in this velocity. Now we are substitute this one, r into 1 minus cos theta plus n minus n square minus sin square theta whole power 1 by 2. So here under root is there. Instead of root we can write as half. That means root becomes half. There is no problem to write half instead of root. So to derivate easily, so we have to change the root into half. That's it. And d theta by t we have to write as same. And now I think you understand the same value what we got in the displacement we have to differentiate. That's it. Then we got the velocity of the piston. So here differentiating this equation. So you have to keenly observe slowly. So then only you will understand this one. So we are differentiating. So this is the r is the constant. So we are removing. That means this is keep aside. So then we are differentiating 1 minus cos theta. So differentiation of 1 it becomes 0, and differentiation of cos theta it becomes minus sin theta. So minus already is there, so minus become plus sin theta. Then differentiation of n it becomes 0, and here n square minus sin square theta whole power half. So in differentiating this whole term we are differentiating as one term. So half comes front. So this is a basic differentiation. Half becomes front, and n square minus sin square theta whole power this one n minus 1 we have to take n into n minus 1. This is a formula. This is the n into x power n minus 1. This is the formula we have to apply here. So that means half becomes front, and that means it becomes front of this equation. And here n minus 1, that means half plus 1 becomes half minus 1 becomes minus half. That's it. And here we are differentiating. So we are differentiate here whole term. That means we have to differentiate these terms again. This is the differentiation rule. That So n square we are differentiating this is the larger value, so we are eliminating. So sin square theta, when we differentiate sin square theta, it becomes minus 2 sin theta cos theta. That's it. So d theta by dt becomes omega. I think you understand this step. So first of all, r we took this constant, we took aside, and differentiation of 1 becomes 0, and differentiation of cos theta becomes sin theta, and differentiation of n becomes 0, and here we are applying this formula. So this is the, we are taking whole term as a one term, these two terms as a one term. So that means here this is the formula we are applying here. So half into n square minus sin square theta, half minus 1, so that means here minus half. So again we have to differentiate this term, so that means n square is the larger value, so we are eliminating, and when we differentiate sin square theta, it becomes minus 2 sin theta cos theta, and d theta by dt equal to, and we are writing as omega. That's it. And from this equation we have to write this one, r into omega, last omega, and this one we have to just simplifying, that's it, r omega we are writing. Then sin theta, here sin theta is there, and minus 2 sin theta cos theta becomes sin 2 theta, so we are writing sin 2 theta by, here minus half is there, so half into, so first of all this term gets completed, we wrote here sin theta, and this omega also completed, we wrote here omega, and next thing minus 2 sin theta cos theta becomes sin 2 theta, we wrote, and finally this is the term left, so we can, here we wrote minus half, that becomes, it becomes under root 2 into under root n square minus sin square theta, it becomes denominator, because why, because it is a minus symbol. So this is a step we completed here. And next step, r omega sin theta plus sin 2 theta by 2n. So here sin square theta is the larger value, so that's what we are eliminating that one. So here sin square theta when eliminates, so here n square is there, so when we cancel the square and root, we become, there is a 2n, that's it, this is a 2n. This sin 2 theta by 2n can be neglected, v equal to r omega cos theta. So in this equation, this is the equation we got finally, r omega into sin theta plus sin 2 theta by 2n. If we eliminate this value, what we get, r omega into sin theta, this is the value we get. So this is the velocity of the piston finding. And next, acceleration of the piston. So velocity by time, so then we get acceleration, that's it. So we are doing what the equation we got, this is the final equation we got from the velocity equation. So r omega into sin theta plus sin 2 theta by 2n we got. So we are differentiating, same this thing, velocity by time. So here again we are writing d theta, multiplication and division, same. So we have to take this one, and we are replacing this velocity by the whatever we find the last equation, velocity equation, we have to write that one in this, d by d theta into r omega into sin theta plus sin 2 theta by 2n into d theta by t becomes omega, and here r omega is there already, and we have to differentiating, no, so we have to take constant as r omega, and differentiation of sin theta becomes cos theta, and differentiation of sin theta becomes here first differentiating this one, so that's what 1 by 2n take as constant aside, then sin 2 theta, when you differentiate the sin 2 theta, there is a sin, you think this sin 2 theta as a theta, this 2 theta becomes theta. If you assume like that, sin theta becomes what, cos theta, cos 2 theta, we are writing 2 theta into, we have to differentiate this 2 theta, when we differentiate this 2 theta becomes 2, so into 2, that becomes cos 2 theta. Here there is a omega, So omega into r omega square cos theta cos 2 theta by n. Just we have to simplify the equation, that's it. So if n is very large, r omega square cos. So when n becomes large, that means connecting rod, when there is a connecting rod is larger value or the larger distance, so we have to eliminate this value and we got r omega square cos theta. So that this is the equation of the simple harmonic. In this is the case of the simple harmonic motion. So we have to say the overview. So we need to find velocity and acceleration. So before finding velocity, we need to know the displacement. Velocity in the sense displacement by time. So we don't know displacement. So that's what we are finding, the displacement. And then velocity. So velocity, displacement by time. We know. Then we find out displacement. So displacement by time, we got the velocity. Then acceleration. Acceleration is the velocity by time. So here we first we find out velocity. So the answer is substituted in the acceleration. Then we got the acceleration equation. So this is the dynamic analysis of slider crank mechanism. So subscribe, like, share and subscribe to my channel Rakesh version. My name is Rakesh, signing off.